two cards A and B are connected by a rope 12 meter long that passes over pulley P. Okay, let's draw a simplified diagram here. I draw a triangle and this is card A in this point here, and card B is in this point here. And this one here on the top of triangle is the pulley P, right? And they are 12 meter long, right? The rope is 12 meter long. So here we will have this rope here that I highlighted yellow is 12 meter long. Okay, and in this case here it's separated into two parts, right? AP and PB. Let's name this as A and let's name this as P. But then we know that the sum of them is 12, right? So I will have A plus B that will equal to 12. Good. Okay, now let's continue. The point Q is on the floor 4 meter directly beneath P and between the cards. So this point here just beneath P is the point Q, and that is 4 meter from P. So I will have 4 here. And then card A is being pulled away from Q at a speed of 0.5 meter per second. So the length of AQ here, let's name this as X, and this card A is being pulled here. So we will have the change of this X here, dx over time. So I'll have dx over dt that will equal to 0.5 meter per second. How fast is card B moving toward Q at the instant when card A is 3 meter from Q? Okay, let's name this as Y. And the question is asking us about this speed here, which is dy dt. And that happens when X here, the distance from A to Q is 3 meters. So I will have X is equal to 3. Good. And I think I will start from this fact here that A plus B is equal to 12. We can differentiate this equation with respect to time because we are looking for the speed, right? Differentiate with respect to time. Okay, this A will change over time. So I will have dA dt. And then plus we will have dB dt here. The change of B with respect to time. And on the right hand side, I will have a 0 because the differentiation of a constant with respect to t is 0. Good. And I think I will leave it there. But I want to see this two right angles triangle. We have AQP with the right angle at Q like this. And then PQB with a right angle at also Q like this. And we can apply Pythagorean theorem to both of them, right? So I will have on the triangle of APQ here, we can have x squared, right? So we'll have x squared plus 4 squared. X squared plus 4 squared, that will equal to the hypotenuse, which is A squared. Good. But we have dA dt here. I think we need to also differentiate this equation with respect to time. So I will differentiate that and I will have 2x, but that is the differentiation with respect to x. By the chain rule, we need to multiply this by dx dt to get it with respect to t. So that is the differentiation of x squared. And then plus 4 squared, that is a constant, so that will be 0 here. I don't need to write it. And on the right hand side, I will have 2a, and then multiplied by dA dt. And I think I will isolate dA dt here. So we will have dA dt, and that will equal to 2x divided by 2a, and then multiplied by dx dt. But that two will cancel each other here. So I have this and this will cancel out. And so we will have dA dt. dA dt. Okay, that is dA. and that will equal to x over a, and then dx dt. Good. Now what? Let's do another Pythagorean theorem, but on this triangle here. So I will have triangle PQB. Okay, and how to calculate that? We will have y squared, and then plus 4 squared, and that will equal to b squared. Right? Okay, take the differentiation with respect to time once again. So I will have 2y dy dt. And this one will be plus 0. And on the right hand side, I will have 2b db dt. Good. And we can isolate for db dt. So we have db dt is equal to 2y divided by 2b multiplied by dy dt. Okay, that 2 will cancel out. So we'll have 2 cancel out. And then we will have db dt. That will equal to y over b multiplied by dy dt. Okay, now what can we do here? We can substitute to equation number 1. So let's plug in into equation number 1. How to plug that in? Remember that we have dA dt here on this side here. So we need to plug that in. And we also have another dB dt here. So we need to plug this in. Okay. So now let's plug in that dA dt here. So I will have x over a, and then multiplied by dx dt. Good. And then plus I will have dB dt here, which is y over b, and then multiplied by dy dt. Okay, because the question is asking us for dy dt, we need to isolate that. So we'll have this is equal to 0. And now we will have y over b multiplied by dy dt. Let's move all of this to the right hand side. So I will have this one is equal to minus x over a, and then multiplied by dx dt. Okay, we need to multiply both sides here. Okay, maybe let's use different color. I think we need to multiply both sides here by b over y. Right? So on the left hand side, this b and b will cancel each other. Right? And then on the right hand side, we can just multiply this. So here on the left hand side, we only have dy dt. But on the right hand side, I will have minus x multiplied by b divided by y multiplied by a, and then multiplied by dx dt. And this is the relationship that we are looking for. Okay, so I think I will use this equation here. Let's put that into a box because that is very important equation for our problem. Okay, but then what we don't have here is space, so let's clean this up here. Okay, so now what we need to do is looking for a specific case when x is equal to 3 meter. So let's do exactly that when x is equal to 3. Okay, we need to find out what is x. We already know it. That is 3. That is given by the problem. But we also need to find out y, b, and a, right? Okay, so let's see what can we get when x is equal to 3. I think we can get a here, right? Because a squared is equal to x squared plus 4 squared, right? That is Pythagorean theorem. But we know x, right? So I will have 3 squared plus 4 squared. That is a squared. And so we'll have a squared that will be 9 plus 16. 9 plus 16, I will have 24. 5. And A is plus minus 5, but the length of triangle is always positive, so I know that A will equal to 5. Okay? But then if A is equal to 5, here remember that A is this part of the rope, B is this part of the rope, and the length of them is 12 meter. So I know that B here has to be 7, right? Because A plus B has to be 12. Remember this one here. So here I will have B is equal to 7. Okay? And then if B is 7, we can also calculate Y, right? Why? Because we will have B squared is equal to 4 squared and then plus Y squared. That is Pythagorean theorem at right angle triangle PQB. Okay, but then we will have B squared here is 7 squared, right? So I will have 7 squared, and that will equal to 4 squared, that will be 16, and we will have plus Y squared. 7 squared is 49. Let's move 16 to the left hand side, so I'll have minus 16, and that will equal to Y squared, and so we'll have Y squared is equal to 33. But then we will have Y here is the square root of 33. Good, now we have all the things, right? We will have X, we also have Y, we also have A, and we also have B. Okay, what we need to do is just to plug in all of the values into this one. So here we will have dy dt when x is equal to 3, we will have x. So I will have minus 3 here, and then b is 7. Okay, that will be 7. And then divided by y is square root of 33. And then multiplied by a is 5. Okay, and then multiplied by dx dt. But dx dt is a constant here, which is 0.5. So I will have 0.5. Okay, and I think we can cancel this 5 and this one into 0.1. Okay, and then we will have this one here, minus 21 multiplied by 0.1. I'll have minus 2.1 divided by square root of 33. Okay, and I think that is the value of this dy dt when x is equal to 3. And that is in meter over second. Okay, but I don't think I'm satisfied with this one. I want to plug this into calculator and get the decimal values. Okay, let's use our calculator then. Where is my calculator? Yeah, this one. We will have minus 2.1 divided by square root of 33. And I will have minus 0.366. Minus 0.366 meter per second. Okay, and the minus sign meaning that the length of y, right, this length of y is decreasing. So y is decreasing. That is why we have negative sign. And I think that's all for this problem. Hopefully I did not make any mistakes during my calculation. Thank you for watching and see you in the next video. Bye bye.